In this problem, we've got a balloon, and to make things easier, it's spherical. And it's being filled with helium at a rate of dV to t, so the rate of change of the volume with respect to time, and that rate of change is 4 pi r squared. And r is given to us as a quarter of t. So even though you got r and dV to t, but this in terms of r, we know that r is a quarter of t, so we can put that in there. So how much gas is being pumped in the balloon in the first 6 minutes, assuming the balloon was initially deflated. So what we want to do is how much gas is pumped in the first 6 minutes. So what's the volume after 6 minutes? And that's saying, well, that when t was equal to 0, the volume was 0 as well. So we get dV to t. So we've done a substitution of r over quarter times a quarter t, and clean that all up gives us pi t squared on 4. So it's just t squared on 16 times the 4 pi. Integrate that, pi t squared on 4 gives us pi t cubed on 12, so we add 1 to the power, divide by the power, add our constant of integration, and we were told initially the volume was 0, so t is equal to 0, v is equal to 0, so that will mean the constant will be equal to 0. Then when t is equal to 6, pi times 6 cubed over 12 would give us 18 pi centimetres cubed as our volume after 6 minutes. In question 6, we've got a vessel contains 100 litres and it's being emptied, and the rate of change of the volume is given to us by this function. The negative, notice, would be because it's being emptied. So first we want to find the initial rate of initial rate dV to t, so that means t is equal to 0. Remember initial, t is equal to 0, sub 0 in, gives us minus 22. So at that point, when initially the rate is decreasing at that rate of 22 litres per minute, so it's decreasing by that amount. How many litres remain after 5 minutes? Well, again, we get our function 2t v, because so we're going to integrate 2, we integrate 20 on t plus 1, so it goes to a log function. So log functions are going to play a part, as can sine and cos and tan. So we integrate that. Again, we've got to find our constant. Now, initially, when t was equal to 0, the volume was 100. So sub those in. That gives us 0. Remember, log of 1 is 0, so that cancels out. Leaves the constant being 0. So therefore, the volume is given to us by that function there, minus of 2t, 20 minus 20 log t minus t plus 1, plus 100. And then after 5 minutes, so when t is equal to 5, what's the volume? We sub it in, we get the minus 10 plus the 100 gives us 90, and minus 20 natural log of 6, and our unit would be litres. So we're just doing an integration, getting our constant of integration, applying all those integral laws and calculus that we've applied onto polynomials, to log and exponentials and the trig, and getting them into a physical problem.